Carrying on with this hydrocarbon worksheet. If you notice here, you've got two bonds. It's a double carbon to carbon bond. That makes that an alkene. Two E's, double bond. And this is another alkene. Double bond. Right. This has got three carbons. This has got 1, 2, 3, 4 carbons. Remember we said monkeys eat peanut butter. Meat eat prop and bute. Meat eat prop and bute. So in this case, because it's an alkene, that means that it's got, right, okay, 1 carbon atom, 2 carbon atom, 3 carbon atom, 4 carbon atoms. So we're after 3 carbon atoms. So it's this one. It will be propene. Propene. And the other one's got 4 carbon atoms. So it'll have the butene. So it's got the bute prefix. Right. Right, this is a weird one. Cyclic. We're not interested in those at this level. We're just interested in these. So this is 1, 2, 3, 4. 1, 2, 3. So from here, the 3 will be propane. It's an alkane, so you got the ane propane, and this will be bute and then ane. There you go. Right, which two hydrocarbons instantly decolorize with bromine water? So adding orange, always just remember the color with it. Add orange bromine water, and if you have an alkene or a if you have an alkene or an unsaturated compound, orange bromine water turns colorless. The other word that they've used here is decolorize. So remember color with the British spelling. So it will be Q and U. Why? Because they are alkenes. The double bond. Q and U, so it's that one we're interested in. Right, which two hydrocarbons have the general formula? So it's got the general formula CnH2n plus 2. So remember what we said. Let me just get rid of this. Right. The easiest way to learn it is learn alkene CnH2n. So if I've got 4 carbons, I double the number of carbons to get the number of hydrogens. So 4 times 2 is 8. Simple. That's an alkene. General formula for an alkene. Now, if I've got an alkane, it's the same thing. CnH2n, but you add 2 more hydrogens. So if it was C4, it would be 4 times 2 is 8. Add 2, which is 10. Right. So So, which two were the alkanes? It was this one, single carbon to carbon bond, and single, single, single. So it's S and T. Which is S and T, that one. Which hydrocarbon is an isomer? So remember what we said, an isomer. Isomer. Right, it's a molecule with the same what? Molecular formula. So molecule with the same molecular formula, but different. I use displayed formula. Displayed. You could use structural as well. Displayed formula. There you go. U. Where's U? U is in molecular formula. 4 carbons and a double bond. Oh, R and V. So A, B, C, D, V. Right, okay. It's got 4. Let's get rid of all this. Clear up the picture. Causing me to think twice. Right. So you have you've got 1, 2, 3, 4 carbons, and you've got 1, 2, 3, 4, 5, 6, 7, 8, 8 hydrogens. 4 carbons and 8 hydrogens. So this has got 1, 2, 3, 4 carbons, and 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So they've got the same molecular formula but different displayed formula. So it is which two letters? So U and V. U, we've been given V. It's that one. So it's U and V. Okay, that was a bit strange, but these strange questions will come up. Right, which two hydrocarbons have the empirical formula CH2? So remember, what did we say about different types of formula? So you've got the first one, which is a molecular formula. And then you've got a displayed formula. Then you've got a structural formula. And then finally, you've got something called an empirical. I always call that empirical. No, it's empirical formula. This basically is where if you've got something like this, I know I can cancel them two down, divide them both by 2, and I end up with CH2. The empirical formula is CH2. So for every 1 carbon atom, I have 2 hydrogen atoms. Right, CH2. So those were the 2 alkenes. The 2 alkenes were U and Q. Is it U and Q? Yeah, U and then Q. Yeah. Okay. Which? Oh, okay. U and Q, and what else? They want for every one carbon you've got two hydrogens. It will be right. I'm a bit confused, so what we're going to do is, to avoid that confusion, we're going to rub everything out and let's try to work this one out. So you've got 3 carbons, C3, 2, 4, 6 hydrogens, H6. Right, so you've got a ratio of 1 to 2. So CH2, that one's okay. So look, for every 1 carbon, 2 hydrogens, 1 carbon, 2 hydrogens, 1 carbon, 2 hydrogens. So that's got CH2. This is not, and this is not. So this has got 1 carbon, 2 hydrogens, 1 carbon, 2 hydrogens, 1 carbon, 2 hydrogens, 1 carbon, 2 hydrogens. So that's got a CH2 empirical formula. So 1 carbon, 2 hydrogens, 1 carbon, and you can see that repeating itself. Right, so I get 4. And so what's the question asking? Which 2 hydrocarbons have the empirical formula CH2? And there's all 4 of them, R and V. So out of the options that they've given is just them 2. So the other 2 they've not given, so we can't include those. So it's definitely not T and S. So it's definitely not anything with an S or an S or a T. So that's the only option. Right, that made me think I thought they were going to ask for all of them, but it doesn't matter. Let's keep moving on. Substitution reaction between hydrocarbon T and bromine is similar to the reaction between methane and bromine. State a condition. So you always need UV, ultraviolet light. Suggest the displayed formula for a possible organic product reaction between T and bromine. Where's T? Okay. So what we're going to do is we're going to do 1, 2, 3, 4. 1, 2, 3, 4. Each carbon atom's got 4. Right. This is compound T. You've got bromine. Remember, bromine's diatomic, runs around in pairs. So what's going to happen is this is going to swap out with that, and that's going to come into there. So let's go ahead and do that. Let's get rid of fuel. Let's get rid of fuel. What color should we use? Let's just use that. Will it like it? Yeah, it will. So Br ends there and H goes there. But normally you'll say hydrogen bromide. And that there, substitution. So we would draw that there. It's only one marker, nothing major. Right. Displayed formula. Right, have you noticed it's got OH in? That tells you it's alcohol group. It's the alcohol group. Give the molecular formula for compound X. So we've got 1, 2, 3 carbons. We've got 3, 6, 7, 8 hydrogens and 1 oxygen. A student describes compound X as saturated and then hydrocarbon. Is he correct? No. Why? Because it contains oxygen, and a hydrocarbon, because there's 3 marks, you've got to just add this, and a hydrocarbon only contains what? Hydrogen and carbon molecules. Right. Compound X and ethanol are members of the homologous series of alcohols. Right. Here they've said they've got similar chemical reactions or similar chemical properties. They have a trend in physical properties. What can you say? They have the same functional group. Functional group. In this case, the functional group is the OH group or the OH group. Do not mix the OH functional group with the hydroxide ion. Okay, careful with that. They have the same general formula. And each successive member goes up by CH2. I don't even know what it is. Right. The reaction produces gas Y and one other product. Okay, so we've got here, it's a dehydration. Aluminium oxide, heat. Right, state the purpose of aluminium oxide. It's acting as a catalyst. It's acting as a catalyst to help speed up the reaction. Right, why can gas Y be collected over water? Because it's insoluble in water. It's insoluble in pani or ubu, water. Ubu, right. Okay, give a reason why first sample of is not pure. Right, the reason that's not pure is because you've got air in here. When that goes across, right, okay, so because the test tube initially contains air, a mixture of air, right? So dehydration, so they want dehydration involves water, so we're removing water, so really we just want to remove that. It can be anyone actually, it's only right. So you've got H2O. What is it saying? Right, okay. Right, when we complete the equation, okay. So you've got C, you've got that, you've got, what do we have there? We have one, right, we'll put a double bond here, 1, 2, 3, 4, so we cannot have a double bond here, so we put a H there, H there, H there, and a H here. Right, now you've got 1, 2, 3 carbons, 1, 2, 3 carbons. We've taken 1, 2, 3, 1, 2, 3, 1, 2, 1. Ooh, right, the other hydrogen has gone over here then. And then we carry on 1, to, no, we don't carry on. Right, I'll take that back, Right, what I need to do is just to make it fair, I'm going to move that hydrogen here, and I am going to remove this one here. That's fairer. Right, so you've got one hydrogen there, that's gone because it was down here, that's gone now. Right, so all those have gone. Right, we are left with 1, 2, 3. We need a, oh, we need 1, 2, 3, 1, 2, 3. Oh, silly person. Did I just do that? I believe I did that. I can't put that there. Do you know why? Because you've got 4 bonds already, so we're going to have to take that back there, I'm afraid. Right, and then I bet this is just cause confusion. 1, 2, I'm going to put that 1, 2, and then can we do that 1, 2? No, you see we can't use this one. That would be cheating. We'd have to use, oh, can I use that? Can I use that? Can I? Yes. We'd have to take that away with that, and then this one here will end up there. So we've got, and then we've got an effect, we'll have to put H2O. That was quite painful. Right, name the gas produced. Yeah, because we dehydrating it, it's gonna be water. Okay. No. No. It's saying name the gas produced. Where are we? So what happens is we remove the water. Oh, so the water is removed. So water travels down here as steam and it'll become part of this. And now the other gas, the alkene, because you've got 3 carbons, 6 hydrogens, is going to be called propene. And that's the one that bubbles up here. So that there is propene. Right, so we have to put propene here, because that water will become part of the water in the trough here, this here. Right, okay, let's move on. Last one. Is this the last one? Yeah, okay. So let's make the most of this. Right, we have fractional distillation to split up crude oil, cracking. Which property of hydrocarbons is used to separate crude oil into fractions? I'm sure I've done this before. It's the melting point. Not melting. Oh my god, did I just say melting point? Oh my god. Boiling point. Because you heat it and it then vaporizes and travels up the fractionating column and is collected there. Did I just say melting point? OMG. Right, I need to focus. Right, B. The main fractions. Right, so we've got bitumen, diesel, fuel oil, gasoline, kerosene, and refinery gases. One use for refinery gases. What's one use for refinery gases? Okay, camping gas. Camping gas. Kerosene is, don't put planes, fuel for planes. Most viscous. Viscous just means thick. It's a thick liquid. And the one at the bottom, bitumen. So it's bitumen. Right. Cracking, catalytic. That just means you use a catalyst. What did you say a catalyst was? Catalyst is a substance that speeds up a reaction by providing a lower activation energy, but is not used up itself. Catalyst used in industrial silica and not aluminium. State the temperature 600 degrees Celsius. Tetradecane can be cracked to make ethene. Right, so look, this is a balancing question. That can be broken up into C2H4. Right, we had 14. We've used 2, so we're left with 12. We had 30. We've used 4. We're left with 26. My maths is right. Draw the displayed formula for ethene. So remember what I said. This comes up so much. It's good to be able to recognize it. Eth tells you that there's 2 carbons, and ene tells you that there's a double bond. Name the polymer formed from ethene. It'll be polythene or polyethene. I remember it as polyethene or polyethene or polythene. Whoa. Polythene. Okay. Why is it difficult to dispose of these polymers? Because they are inert and do not biodegrade. There you go. Right, that was it. That is hydrocarbons done. That was quite painful, but no pain, no gain. See you in the next one, inshallah.